Hey geometry classes, we're going to take a look at special right triangles through an exploration, and then there will be a second video that's a follow-up. So the idea is that you should explore this because the more exploration you have on it, then the more ownership you have in your learning and the more likelihood you are to remember it. This lesson really ends up with some pretty handy shortcuts for finding sides of special right triangles, which are going to be really helpful in the quadrilaterals unit. They would probably be helpful in the SAT if you ran into them in terms of saving time, but they'll show up quite a bit in our next unit. So make sure that you pay close attention. Okay, so we're going to start with defining the type of triangle that we're going to be working with. The first type of triangle is a right isosceles triangle. Okay, so it says label the measure of each angle. So if it's right isosceles, that means we've got a right angle here. And if it's isosceles, we've got two congruent sides. Well, if we've got two congruent sides, then it means our base angles are congruent. And so when you do 180 minus 90, you're left with 90, and divide that by 2, you get 45 for each of these base angles. So another way to name this triangle is by its angles, and we can call this a 45, 45, 90 triangle. Okay, so part 3 says that each triangle below is an isosceles, a right isosceles triangle, or a 45, 45, 90. Mark and label the triangles appropriately. Then use the Pythagorean theorem to find the measure of each side of the triangle in simplest radical form. So make sure you do not use any decimals, etc. All right, so what I will do A with you and explain what I mean, but so we know this is a 45, 45, 90. So that means it's right isosceles. We've got two congruent legs that are both congruent, so those are both 1 and 1, and a right angle here, and then two 45-degree angles here. And what we need to do is, finding the legs is pretty straightforward, but we actually need to find the hypotenuse. So we're going to use the Pythagorean theorem. So we're going to do 1 squared plus 1 squared is equal to, we can call it C squared. So 1 squared is 1, and 1 plus 1 is 2. So C squared is equal to 2. So to find the length of the hypotenuse, we're going to take the square root. We would get C equals plus or minus root 2, but we're only concerned about the positive length since it is the side length of a triangle. So that hypotenuse is equal to the square root of 2. All right. So you need to stop the video now and work in a small group and do triangles B, C, and then D as well.